Hi, everyone. Since I can't be there with you for a couple weeks now that I'm in quarantine, I'm going to go ahead and do the lessons with you this way. So you should have your packet of Chapter 4 notes in front of you, and we're just going to start Chapter 4, so you'll follow along with me here. Today we're just going to do the first section of Chapter 4, where we talk about slope of a line. So when you think slope of a line, maybe you think of like skiing slopes. And the reason for that is when we're talking about slope, we're talking about how steep something is, which when you think of skiing might be how steep the hill is, right? Maybe it's a really steep hill or maybe it's not so steep, but pretty important to pay attention to if you're going to go skiing, right? So we're just talking about the incline, how quickly the hill or our line in today's case is going up or down. Is it very steep or not so steep? So in your notes, you'll see here where it says slope is the rate of change between any 2 points on a line. So we are going to pick 2 points on a line, any 2 points, and just find what the rate of change is. That rate of change is going to tell us how steep that line is, how quickly it's going up. Is it a very steep line, something that would be kind of scary to ski down, or is it a pretty slow incline, something that might not be so intimidating if you're a skier? So here on the screen, you see it says slope equals change in y over change in x, or rise over run. We're going to look at how we use that to calculate the slope of a line. So you'll see this same graph on your notes that I have here on the screen. And on your notes, you'll see we've got these 2 closed points here. They're red on my screen. And the 2 open circles, they're blue here on my screen. We're going to calculate the point or the slope between the 2 red points first. And to do that, you saw that we use rise over run, okay? And I'll tell you exactly what I mean by that. So to do rise over run, we always start with the point furthest to the left. Since we're doing the closed points first, we're going to go to the closed point furthest to the left. So put your pencil on the closed point furthest to the left like I have done here on the screen. And then we rise, right? It's rise over run. Now, to go from this red point to the next red point, I can't rise up. I have to rise by going down. So I'm going to just draw a line going down until it's level with the next red point. That's my rise. And we say to be level with the next red point, we had to rise down 1. So we're going to say this is 1 unit. And since we went down 1, we make it a -1. Whenever we move down, we make it negative. And then we run. So now to run, that just means we go over. So I'm going to draw my line going over until I reach that second red point. And we count that we ran over 2 units, and so we'll label that here. So since we said slope is rise over run, we rose -1 and we ran 2. So my slope of this line is -1/2. Okay, that's the steepness of the line between the 2 red points where we just calculated. Notice when we did rise over run, we created like a right triangle here. That's what it's going to look like every time. So every time you do slope, you're going to make that right triangle where you draw your rise over run, and then we just count, make it a fraction. So we're going to do the same thing between the blue points. So put your pencil on the blue point furthest to the left. I know they're not blue on your paper, so the open circle furthest to left. We always go left to right. So pencil on the point furthest to the left. And then we're going to count how many do we rise. So again, we have to go down until we're level with the next open circle. If I count, we went down 1, 2, 3, 4 units. So we're going to label our rise as a 4. Since we went down 4, we're going to make it a -4. And then we run. So we're going to then draw our right triangle running over to the next blue open circle and count how many units we ran. In this case, 1, 2, 3, 4, 5, 6, 7, 8. So we're going to label our run as 8. So now we have our rise, -4, over our run, 8. And so my slope here is -4/8, which we can simplify. If you can simplify your slope, we always want to do that. We can say 4 and 8 are both divisible by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. So now we have simplified our slope to -1/2. Now, if you notice, that was the slope we got between the two solid points, right? So the slope between my two solid points is -1/2. The slope between my two open circles is -1/2. There's a reason for that. Anytime that we have a straight line, no matter what 2 points we use, our slope should always be the same. That line is increasing or decreasing at the same rate no matter where we go because the line is straight. If we had a curved line, then our rate of change would be changing. But since it's a straight line, it has what we call a constant rate of change. The rate of change will always be the same. So when we're calculating slope, it doesn't matter what 2 points on the line we use. We can pick any 2 points on the line we want to find our slope. It'll be the same as if everybody else in your class picked a different 2 points. We should all arrive at the same answer. Okay, so let's look at another example. Okay, so we should be looking at the next example. Again, we've got 2 closed points and 2 open points. So we're going to start by finding the slope between our 2 closed points. So we'll do rise over run, always left to right. So we're going to put our pencil, so do that with me. Everybody put your pencil on the point furthest to the left. Then we're going to rise. This time the line's going up. So we're going to rise up, draw our line going straight up until it's level with the next red point. And we'll count. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we went up 9. There's our rise. Then we run over. So now we're going to run across. We'll always run to the right no matter what. Rise over run. You can rise up or down, but you'll always run to the right because we're going left to right. If you're running to the left, you're doing it backwards. Always run to the right. So up 9, over 1, 2, 3. So our rise was 9. Our run is 3. So we can write that as a fraction. Rise over run. 9 over 3. We always want to simplify if we can. So we can say 9 and 3 are both divisible by 3. 3 goes into 9 3 times, and 3 goes into 1 1 times. We can make that 3 over 1. And anytime 1 is in our denominator, we can write it as a whole number, so just 3. Okay, so now we know the slope of my line between the 2 red points is 3. And we said the slope should be the same between any 2 points we pick on the line. So let's test that now with our open circles. So we're going to do rise over run from the first open circle to the second, always left to right. So put your pencil on the circle furthest to the left, and then rise up until we're level with the next open circle. And then we're going to run over to the right until we meet up with that open circle. So rise up, we can count 1, 2, 3. Over 1, we write that as the fraction, rise over run. And so we have 3 over 1, which we can simplify since 1 is in the denominator to just 3. And we ended up with the same slope between the 2 points, which is exactly what we want to see. The slope should be the same between any 2 points we pick on the line. So again, it doesn't matter where you pick your points. No matter where we pick our points on the line, the slope is always the same. So there are 4 different types of slopes that we're going to run into as we're calculating our slope of a line. So the first type of slope we're going to see is a positive slope. And we know a line has a positive slope when we see that it's moving up from left to right. Everything we do with slope in our lines is going to be from left to right. So just like you would read a book, or read a sentence from left to right. In math, it works the same way. We read a graph from left to right. So we're always looking at the line from the left to the right. So if I look at this line from left to right, we can see that the line is going up. So this line's going, if we go left to right, up. Just like you can see in my examples here. This mountain here from left to right, right here, that's going up. The staircase from left to right is going up. The roller coaster from left to right is going up. From left to right, if it's going up, we should have a positive slope. If you ever get a negative slope and your line's going up, you need to go back and check. You probably did it backwards. Slope is always positive when the line is going up. Okay, if you get a negative number, it's not right. So let's look at this example. We've got our line, and if I asked you to find the slope of this line, you would just have to pick any 2 points on the line that you wanted. Remember, we said it doesn't matter. We're going to get the same slope no matter what 2 points we pick. So maybe I just find a point. This one looks fine right here. So I'm going to put a point on the line. Do this with me in your notes. And then pick another point on the line. So maybe I pick this one right here. Any 2 points will do. So pick 2 points on the line in your notes and try doing your rise over run. You might get something different than I do at first because maybe we're using different points, but they should all simplify to the same thing. So let's try it. Go ahead and count your rise over run. And so you can see on my screen when I did rise over run, I went up 3 over 3. So I'm going to write that as my slope, rise over run, 3 over 3, which simplifies to 1 over 1. Whenever 1's in the denominator, we can make it a whole number. So we can say our slope here is 1. Maybe you went up 2 over 2. 2 over 2 still simplifies to 1. Or maybe you just went up 1 over 1. 1 over 1 simplifies to just 1. So no matter what 2 points you use, we should get the slope 1. Notice it's positive 1 because the line is going up. Okay. Also, pay close attention that we went from left to right. The biggest mistake people make when we do this is they decide to go backwards and they started a point on the right and go down and over. Don't do that. You're going to end up with a negative 3, and then people end up telling me that the slope is negative 3 over 3, which is negative 1, and that's not true. The line is going up. You just went backwards, so you had to go down. Don't do that. Always go left to right. So if it's going up, we should be going up, then over. Always left to right, not right to left. Okay, that's important. So the next type of slope that we're going to run into is what we call a negative slope. We have a negative slope if the line is going down from left to right. So positive goes up, negative is going down, again, always from left to right. So if we look at this line from left to right, we can see that it is going down. Just like you can see in my examples over here, our ski slope from left to right is going down. It's a negative slope. Whoops. The roof from left to right is moving down right here. And if we look at this side of the bridge from left to right, it is going down over here. Negative slope is where we have our line moving downward. So if we want to calculate the slope of this line, we know already because it's going down that we need to get a slope that is negative. Our answer has to be negative if the line is going down. Again, we can pick any 2 points on the line that we want. So we're going to go ahead and plot 2 points on the line. Any 2 points, it doesn't matter. So pick 2 points and plot them on your line. I'm going to do the same. Pick maybe points different than I do. Again, we'll get the same answer. So put 2 points. I'll pick maybe this one and this one. 2 points on the line. Any 2 points will do. Just don't pick a point that's like in the middle of a grid. Pick an actual coordinate point that is where those grid lines meet up. You don't want to have to deal with fractions and all of that. So pick 2 actual coordinate points here where those grids meet up. Do your rise over run. So in mine, I'm going down and then over. And we can see I'm going down 1, 2, 3, 4. Since we went down 4, I have to make the slope -4. And then over 1, 2, 3, 4. So I can say my run is +4. So when I write my slope, rise over run, I have -4 over 4, which I can simplify. 4 goes into 4 one time, so -1 over 1. And 1's my denominator, so I can write that as a whole number. So my slope here is just -1. And we want to see that the slope is negative because the line is going down. It should have a negative slope. Okay. Always try to double check that. If your line is going down, make sure the slope is negative. If the line is going up, make sure the slope is positive. So sometimes we might see that a slope is not really positive or negative. Okay, so in this case, you'll see that my line is horizontal. If the line is horizontal, it's not really going up or down. So let's say we go to calculate the slope of this line. Go ahead and pick 2 points on the line so we can get our slope here. So maybe I pick this point here. You can pick 2 points. Any 2 points are fine. When I put my 2 points on the line and go to do rise over run, put my point here, how many units am I going to have to rise up? Probably 0, right? It's already in line with the next point. So I'm not going to go up any. That makes my rise 0. And then I'm running over 1, 2, 3. So I'm going up 0 over 3. And so when I have 0 over anything, when 0 is my numerator, 0 over anything is just 0. And so there's my slope. Whenever we have a horizontal line, the slope is automatically 0 every time. So our last type of slope that we're going to see when we're looking at slopes of a line is what we call undefined. And we run into undefined slopes when we have a vertical line. So we need to remember that that horizontal line we just saw always has a slope of 0. But a vertical line, when it goes straight up and down like this, ends up with a slope that's undefined. So let's look at why this is undefined as opposed to 0 like a horizontal line. To do that, we need to go ahead and do our rise over run again. So we're going to pick 2 points on the line. Any 2 points will do, doesn't matter, it's a straight line, so we're going to get the same slope no matter what. And then we just do rise over run from one point to the next. So if I do that here, we're going to see that I have to rise up 1, 2, 3, 4 units. Oops, 4 units. And over, I'm already in line with my next point, so over 0. So my slope here is going to be 4 over 0. And you might be thinking, well, isn't 4 over 0, 0? And actually, no, it's not. 0 divided by anything is 0. So when 0 is in our numerator, like it was for the horizontal line, then it is 0. When 0 is in the numerator, 0 divided by anything is 0. But can we divide by 0? And the answer here is no. We cannot divide by 0. Siri has a really good example for this. For those of you with iPhones, I don't know if you've ever asked Siri to divide by 0, but if you did, she has several different responses, so you might have to try a few times. Don't do it now. Your phones should not be out. Try it when you get home. But if you asked her to divide by 0, she does give one answer that's something along the lines of, if we had 4 divided by 0, that would mean that you have 4 cookies to share amongst 0 friends, right? If you remember back in elementary school when you learned to divide, you were breaking things up into groups. So your teacher might say, if you have 4 cookies to share with 2 friends, how many cookies does each friend get? And then you would divide it into those groups. Well, here you have 4 cookies, but 0 people to share it with. So how many cookies does each friend get? Well, it doesn't make sense because you don't even have friends to share it with. And then she has some really snarky response about how you have no friends and Cookie Monster is sad. And I'm sure those of you that I'm talking about probably know better exactly how she says that. But it is a good example to help you kind of visualize and understand. We can't divide by 0 because there are no groups for us to even break that into. So 0 cannot be on the denominator. When 0 is on the denominator, it just doesn't make sense. So we say it is undefined. There's really no answer. And so whenever we have a vertical line, 0 ends up being the run, which is the denominator, which means there is no answer. It's undefined. So anytime we see a vertical line, we always just say that our slope is undefined. And that would be the answer you would write out on paper for me or type into the computer for me if you saw a vertical line, is that the answer is just undefined. Or if you saw a horizontal line, you would just say that the slope is 0. Okay, so those are things you just need to remember as you're looking over your notes to study for the next test or quiz. That's definitely something you want to make sure you study. And that covers it for what we're going to do today. Today, we're just practicing rise over run, up then over, left to right, to find the steepness of a line. How steep is the line? That's the slope. The bigger the slope, the steeper the line. So we do need to know that if a line had a slope of 9, that would be much, much steeper than a line with a slope of 3. Or a line with a slope of 3 would be much steeper than a line with a slope of 1/2, right? Because 3 is greater than 1/2. So the bigger the number, the steeper the slope. The smaller the number, the less steep the slope. If the slope is positive, we know the line's going up. If it's negative, the line is going down. So you guys are going to do some practice today on Nearpod. You're going to work through it at your own pace today since I'm not going to be there to do it with you. And on that Nearpod assignment, I want to see that you're drawing the triangles for each of those lines. So I want to see if you're looking at a line. So let me just kind of give you an example. That you put your 2 points, any 2 points are fine. You're going to put your little cursor on the point furthest to the left, and you're going to draw that triangle for me where you show me you went up and then over. And then you're going to write the fraction for me as the slope, rise over, run, whatever it ends up being. And so you're going to practice that several times on Nearpod at your own pace. You're going to try to get through all of them today with the remainder of class time. It comes through to me in real time. You don't have to worry about saving or submitting. Submit each answer, but when you're done, you don't have to worry about saving anything. It all comes through in real time, so you'll be good. So make sure you get through a good amount of that, as much as you can today in class. And then make sure you check Google Classroom tomorrow on your remote day. I will be posting on the stream each day that you're remote what assignment you need to be working on. So tomorrow for your remote day, make sure you go to our stream, look for the assignment. It'll be there, and you'll be practicing some slope a little bit more tomorrow at home. All right. So I'll see you guys later. Good luck. You can always email me if you have any questions. Bye.